All
All
in.
right.
All right, so I'm clicking. All right, so our group is Wes, Christian, and then me, Tommy. We are doing a model rocket with interchangeable fins, nose cones, really a whole lot of modularity to the thing. Wrong button. So, Wes, this is you.
Yeah, so for the product design, we were thinking of having first bottom fins to as incorporate a very beginner level mindset as what when people go into learning about rockets, this is what they first envision. Either one, the bottom fins, or either two, the arc fins. Um, Depending, the issue or what we try to plan for is what kind of latch we are going to be building. Uh, it's either going to be snap-on with a 3D printed or some other material or Velcro. Or another idea that we're going into is also magnets as well, as for our product design.
All right, and up next we have the reasons for our design. So, a modularity to the rocket would allow for easier storage of the device because if you have the bulky fins sticking out from the sides of the rocket, that adds on an extra like, 5, 6 inches of just wasted space where you can't really store it anywhere. But if you're able to take off those fins, you can put those 6 inches down to like not even an inch with the height and length of the rocket. And then a cavity within the body, which will be a very important part because first off, it'll make it light enough to actually launch. Because if it's a full, just complete solid all throughout, then the rocket's not going anywhere. So first off, it would make it lighter, but also equally as important would be it would allow for the placement of some sort of fuel, such as a carbon dioxide, CO2 canister or just air canister, something that can hold air to launch the rocket from the ground. And then also, somewhere within the body would go possibly a parachute to, lessen the fall of the rocket where its ground. And then, of course, interchangeable fins will allow for air experimentation with aerodynamics and physics and just how a different shape and size will just impact everything to do with the rocket. And then what we're expecting to kind of change throughout all this is first off the size and placement of the wings. So far, we haven't settled on any exact like way we're going to hold on the wings to the rocket, and that's a very important part of the shape because currently the way we have our rocket designed is that the fins go up through the bottom and cover the middle, which makes it impossible to actually mount any sort of canister for launching it from the ground, which is very counterintuitive for a model rocket. And then most likely we will add a parachute of some sort into the rocket because the whole idea of this is that it will be reusable so that you can switch out whatever you want and see what happens. But if there's no parachute, the odds of it breaking after each and every use are greater and greater, which we don't want. And of course, the mechanism for propulsion may change because we were discussing this with like in front of classmates, and they gave some very good suggestions with other than just carbon like CO2 canisters, which are wasteful, not necessarily cheap, and they're not reusable. You use them once and then you throw them in the trash. What some of our classmates suggested were we could use like a pressurized soda bottle, which could, be refilled by just pumping it up with a bike pump or of some sort, something like that, and then just attaching it to the rocket and have that be the ways of propulsion. And then another student suggested having an sorry, I don't know exactly how to pronounce this, Estes rocket engine, which is kind of like a fuel Basically, it's a fuel to launch the rocket with great velocity. And so those are what we're expecting to change and everything about the design we have so far. Right, Christian?
And then the target demographic. So the target demographic we're looking for are either rocket enthusiasts or just any students. So the reason why I say students as well is because this model rocket can show aerodynamics and physics. So it can show like how weight impacts it, thrust, lift, and drag. So like Tommy said before, we're gonna do interchangeable parts, and what that does is that the cones and fins are gonna have different shapes, sizes and weight, which affects the trajectory of the rocket itself, which is great for showing students or like rocket enthusiasts how it works. So yeah.